In this video, I'll discuss solutions to the third SQL assignment. Some students had some questions, so I thought it would be a good idea to produce a video. Okay, so some of the questions are based on the college database. And in the college database, you know that there's a table called students, there's a table called instructors, then you've got the courses and sections and registrations. Okay, now the important point here is that for every course, there could be many sections. And if you look carefully at the sections table, you would realize that in order to identify a section, you need to provide both the course ID and the section name. Course ID itself repeats, as you can see, and section name also repeats, but the combination of course ID and section name is unique. Okay, which is the case, for example, at our university. That's how things work. Okay, so the instructor ID tells you which instructor is teaching a particular section, and then you've got the reservations table and that the registrations table, I'm sorry, that's telling you for each section students who are registered. So for example, in course number 10, section number AA, you've got students 11, 1, 14, 18, 4, and 15 are all registered in that one section. Another important point to note about this particular database is the fact that between the sections table and the registrations table, there are two columns which are common, course ID and section name. So if you do want to join these two tables, you have to join them on both of those columns. Okay, and that occurs in some of the questions. Okay, let's jump right to question number 1. It says list student names, first and last names, and the course ID and section name for each student they are registered for, each section they are registered for. Okay, so the point here is that you need the student names, which are going to come from the student table, and you need all of the other details about the section, which is going to come from the section table. Okay, you don't need the course name, and therefore you don't need the course table. Course ID and section name are both available in the sections table itself. Okay, therefore just a simple join of the two tables will do the job for us. So we are saying list first name, last name, course ID, section name from students S, join registrations R, right? Because that's where the information about students registering for courses is, and on s.student ID is r.student ID. Okay, so that's easy, straightforward join of two tables.
Let us now move on to question number 2. It says, same as previous question, but for students who have no registrations, list the student name and null for the section details, right? In other words, what you're saying is, for students who have registrations, do it as before. For students who don't have any registration, right, that is, they have not registered for any courses, leave the columns from the registration details, in other words, course ID, section name, etc., leave them blank or null. Okay, that's all we are doing here. So this is a case where we are saying that typically when you do a join, you get results only when there are matches. When there are no matches, you don't get any results. Whereas sometimes, even when there are no matches, you want some information from one of the tables to be included. And in this particular example, that one table which we want to be included is our students table, right? So therefore, we say select all these from students S. Now, instead of just saying regular join, we are saying left join. Okay, that is because we want students table to take priority. In other words, even if there's no match, we want student details to be listed. So that means it gets priority. And therefore, we say students left join registrations. Okay, now just to be clear about left and right, essentially what we're saying is we are mentioning one table first, students, another table later, registrations. The table we mention first is called the left table. So when we say left join, what we are saying is, well, give priority to the table on the left or the table mentioned first. So even if there are no matches, all the columns, selected columns from that table will still show up in the result. Okay, so we did left join and everything else is just the same as before. Okay, now of course, whether you use left join or right join depends upon the order in which you mention the tables. So if I mention the tables in a different order from registrations are and then joins as students, then I will now say right join because I still want details from the students table to be printed even if there are no matches. Okay, so that means I now have to say the students table is the one that is mentioned second and is therefore called the right table. And for it to take precedence, I now have to say right join instead of left join. And the third line looks just the same. The last line, the fourth line of the query looks just the same. Okay, so this is an example that uses outer joins. Left join and right join are both called outer joins. And in case you've still got some questions about outer joins, please do refer to the handout that I have posted on outer joins. That will definitely clear up matters for you. It's got a couple of simple examples and so on. Okay, so you could always look at that.
Let us now move on to question number 3. So in this question, we are saying list the student names, first and last names, and the count of their registrations. Okay, so we want to count how many registrations each student has. Okay, that is the number of sections that each student is registered for. Okay, now remember, the registrations table tells us the course ID, the section name, and the student ID. Okay, so all we have to do is to take the registrations table, join it with the students table, group it by student details, and we have the job done. Okay, so this is pretty straightforward. So what we're going to do is select first name, last name, and count star, because obviously we want the number of sections each student is registered for. And since we don't want the course name, the course table need not be involved in this at all. We can just manage everything from the registrations table and the students table, right? Because we're just saying how many sections each student has taken. So we first take students, join it with registrations, and of course we join it based on student ID. The important point is to group it by first name and last name of student, right? Because we're saying for every student, give me the count. Okay, for every student, give me the count of how many sections they registered for. So therefore, we say group by first name, last name, because each of the groups is a particular student. Okay, so that's the idea here. And the beauty is that whenever you have in your select clause a mixture of aggregate functions like count star and non-aggregates like first name and last name, then you really need to think about it, right? You're saying for every combination of student first name and last name, I want a count of something, which clearly means the first name and last name can occur many times. Okay, but we want to collapse it into a single count. Okay, so whenever you have this kind of a situation where you're mixing aggregates and non-aggregates, you always have to group by the non-aggregates. So in this case, you have to group by first name and last name, otherwise it just will not make any sense at all. Okay, so this is something that I had explained in the video, and as part of our hybrid recitation sessions also, I'm covering the same thing. The first session, which is already complete, I've covered it, and I will be covering it again in this week's class. Okay, so that's the point that I'm explaining here. You can read this. This is what I have stated. I'll be posting these slides so you can use these as notes for your benefit. Okay, so the next question says, it's basically same as the previous question, but important point is, for students who have no registrations, show a count of 0. Okay, now this is an important point, conceptual point that this question is illustrating, right? So normally, suppose you just did a join like this. Okay, now in this, what will happen is, will this not show a count of 0 for students who have not registered for any course? It won't, because when you take a look at the join, right, in this joined table of students joined with registrations, students who have no registrations are not even part of this joined table, right? Remember, we are doing a regular join, and with a regular join, students records that have no match between the two tables They don't even figure, right? So the only counts you will see here are 1 and more, not 1 or more, but not any zeros. Because if there were zeros, then zeros just won't figure at all, because if there is no match, then there is not even any record in the output. So count star will have at least 1, never a 0. Okay, so that is why this doesn't do the job, and therefore we are asking this question. For students who have no registrations, I want to see a count of 0. Okay, so to do this, we use a special feature of SQL, which is to count the values of a particular column. Right? Till now, we have just been saying count star, but here we are saying count r.studentID. Right? What this does is, when you say count a specific column, it counts only the non-null values. Any null values are ignored. Right? So when you combine this with our capability of outer joins, okay, so this time I'm doing students left join registrations. That's an outer join, which means that for students who have no registrations, r.studentID will be null, but the student name will still appear, right? So you'll have the first and last name, but the registration from any columns from the registration table will all be null. Okay, and then when you count those columns, those nulls will not be counted, and therefore students who have no registrations will still be shown a count of 0. This is a very key aspect of this particular query. I think you should pay a lot of attention to this. It's important, right? When you use count of a particular column, it doesn't count the nulls. Okay, so in these kind of scenarios, you precisely need to use this capability. Of course, you've joined the two tables, registration and students, on the student ID. Of course, as I've already pointed out, you've got an aggregate and non-aggregates. Of course, you have to group by both the non-aggregates. Okay, so once again, I've explained all the details here. When you look at the PDF of the slides, you can follow on with this.